Today we're going to talk about inputs, adding inputs to ReEDS, and then touch base on outputs a little bit here too, just to hopefully make this cleaner, more straightforward. So I'm going to share my screen. So I have here repository. This is the open access repository as it sits today. So this is the 2020 version of the model. Sorry, 2021 version of the model. So everything should be consistent with what you see online. So I don't have anything different here. So the inputs primarily reside in this inputs folder. We have other videos that you could connect with that walk through these and what's in all these different folders. I'm going to go through adding a couple different types of inputs or changing a couple of types of inputs just so you see what's going on and what's happening there. So one of the common inputs that people look at or want to change are costs. So those are all in this plant characteristics folder. You can see there's already quite a few costs in here. So we have battery costs with the different ATB stands for annual technology baseline, where we pulled from different years of the ATB. And then we've got the advanced, conservative, and moderate cases out of those. So for battery costs, for conventional technologies, geothermal. So you can see the main ATB categories with their costs in here. You'll also see other things like this renewable energy combustion turbine. We've changed that to hydrogen combustion turbine, and things like BECCS for biomass energy with carbon capture and sequestration. So these are all in here. So if you want to come change something, first piece that's pretty straightforward is I'm just going to use the battery cost as an example. So let's say you want to change your battery cost. One thing you could do here is just open this guy up, and you could just change something. For example, maybe one thing you want to change is so these costs are all contained in the technology baseline. I pulled that here. So here's the 2021 ATB spreadsheet. Let's go to the battery cost tab, and let's say you wanted to change something. You could just change something in here and port it over. But for example, there's one thing that the FOM we assume is 2.5% of whatever the capital cost is. So that's how we get the fixed operation and maintenance cost. Let's say that you think, oh, my new battery technology, the whatever I'm going to model, we think it's actually going to be 1%. So I'm going to go in here, I'm going to change these values to 1% for the 2-hour battery, and then I've got new costs for my battery case here, and I want to put those in. So I'm just going to take these and drop them in over the top of the other ones. So we'll take them and put in I guess I don't even have to do it in here. We can just do it this way. We'll just do it this way. We're just going to say I'm going to change my thing to be 1% of my capital costs instead of 2.5%. I'm just going to put it in here. Now I've got a new case. I could just save this and run it, and we're done. Like, that'll take care of it. So that's the most straightforward way to change inputs. When you set up your run in your cases file, it's already pointing to this thing. So if we open this up, this battery scenario is already saying use the battery ATB 2021 moderate case, which is the file we were looking at here. So it would just already use this stuff. So that's a pretty easy thing to do. But let's say instead of using this one directly, we want to call this something different. So it has a different name. Maybe we want to compare it against this scenario. So we want to run our battery ATB 2021 against our battery ATB 2021 with a lower FOM. So we could save this guy in our folder and call it the same thing, but I'm going to put a low FOM on the end of it. And now in my cases file, if I want to run that case, so I'm going to say here's my reference case. So this is a reminder: each column is a separate run. So however many columns you have, that's how many runs you're going to have. These ones are already set to ignore. They've got the ignore switch set to 1, so these won't get run. So I'm just going to delete them. And now I'm going to have another one where I'm going to have a rep, and it's going to be low FOM. So now I'm just going to call this my general ref. So these are going to be the scenario names. And I'm going to, instead of giving it this as the default, so if there's no value in here, it takes the default. So now instead of taking default, I'm going to give it this, but put in the low FOM. And now this one will run that case. I could compare these with each other. The only piece you're going to have to either remember, or if you don't remember, it'll fail because this won't happen. Or because there'll be a problem in here, is we are running this and it needs to know what dollar year everything is. So there's this dollar year file that says what every file in here, what dollar year it's using. So you can see this one is using $2019. So because we added a new scenario, we need to stick it in here and tell it that this is the dollar year of the new file we created. So since it's the same as this one, that's fine. It's easy. You just have to copy and stick it. Otherwise, it'll say, "Hey, we can't find the dollar year for this thing." It doesn't know how to convert it. So everything in ReEDS, when you get inside of ReEDS, it converts everything to $2004. So that's why it needs to know what dollar year it is to be able to do that conversion. So let's just run it, make sure it works. So we're just going to run the run batch file. Oh, and actually, you know what, just to make sure it runs faster, let me go back to our cases file. And I'm going to set the end year. It's set to run to 2050. I'm going to tell it just to run to 2020. Actually, we'll just run it to 2012 on both of these just so we get it faster. So it'll go fast. Otherwise, it might take quite a while. So I'll have it, ReEDS starts in 2010. So we're just going to have it run those two historical years. And so we'll have it run. It says we'll go batch prefix. We'll call this low FOM test. And which case file do we want to run? We're just using the default case file, so we don't have to put anything in there. So it says, here's our two cases we want to run. How many do you want to run simultaneously? They're both super small, so I think I could run them both at the same time. And so we'll just run through them and we'll check them here in a minute. Just as that's going, just a reminder for as you're looking at, here, what kinds of things do I want to set up? We have our cases standard scenarios file, which has all of the standard scenarios in it. There were 50 of them last year. So if you want to just look at like, hey, what kinds of things could I change already that maybe I don't need a separate input for, you can always open up this guy and see what's in here. So there's 50 scenarios in here. So you get the count here. There's 50 different things set up here. But these are really handy for like, oh, look, there's already low demand growth scenario. There's already an electrification scenario. There's already low natural gas price scenarios. So there's already a lot of pieces in here, as well as these other 95% by 2050 carbon reduction scenarios. So you can look at the standard scenarios report. It describes the different scenarios. And if you wanted to set one up for, maybe you just want to modify one, then you can just come in here and say, oh, this is how you run a high natural gas price scenario. If it's using a different rooftop PV, behind the meter PV scenario, where it's using a high natural gas price scenario, because the prices would be higher on the end use, so you get more adoption. And then we're using the AEO 2021 low oil and gas scenario as a natural gas price input. So you could use this to look at different inputs, and then it's like, oh, I want an even higher gas scenario. You can come look at this and like, oh, this is the file I want to look at changing, so that you could see what, how you might want to modify things there. So this could be a really helpful reference for just understanding what the inputs are and what you want to change. The other thing with inputs is we have, back to this cases file, we have a whole bunch of switches that configure scenarios. So as you can see here, if we go down to the bottom of this, there are 220 rows. It's kind of an overwhelming number of switches in some ways. We keep adding more because we keep wanting to test more things and be able to control whether or not we turn them on and off. So again, that's where the standard scenarios file is helpful to see what kinds of things you might change for something. So we have a low transmission scenario and a high transmission scenario, and you can see what switches get changed. Any switch not in this, we'll just use the default in the cases file. But this could also be a way to look at different inputs and just browse it and see, read through the descriptions, what they mean, and then that could help you just, is this something I might want to do? So, here's this one turns on and off the VEX technology. So we like having that because VEX is not a commercial technology. So maybe you want to turn it off or make it available or not available. So there's a lot you could do with inputs that are already defined. Okay, so our two scenarios are cranking away over here. So let me come back to our command window. So you'll see this, and then once things get going, it kicks off these two separate windows where it's running things. So these are the two scenarios where it sets up the model and solves it. This one's solving the second year, so it's almost done. So once you have a run kicked off, you'll have this runs folder. We'll create those two files. So we've done that here. And let's check our inputs. So we could do this even while it's going. So inside of our runs folder, it makes a copy of everything that needs. So this is now a self-contained folder, so it can run everything in here. Most of the inputs are put into this inputs case folder, and there's a bunch of Python files that run up front that will do processing and put things in a format that can be read into GAMS. Those all fall into here, and then the GAMS is reading from here. So let's get these out of the way so they're not distracting for us. So a couple things that are useful. One is just if you have any files in here, you can look at them directly to see what the inputs are that are going into a model. The other thing that's really helpful is there's this inputs GDX file that gets created. This happens at the after all the inputs have been processed. This happens before the model starts going in to solve anything. So the model reads in all the inputs, and then it sets up the model, and then it starts working through the solve sequence each year. So solve 2010 and 2012, etc. So when we open this file, we have this inputs .gdx file that has everything that's in the model. So we dump everything out before the model starts. So we could look now at the O&M cost to make sure they got ported in correctly. So we changed the FOM. So we have this cost FOM parameter, and it's got the battery 2, and it says here's what the FOM costs are for the 2-hour battery and for the 4-hour battery. We only have the 2 years here because we only ran it for 2 years. So we can make sure that these are what we expect them to be. These are going to be in the raw models. You can see they're $2,004 per megawatt year. So that's our units for the fixed O&M. We could look at them. I'm going to close this other one so we don't get confused about what else is here. So we open that for the low FOM test, and we could go here and we could look at this one too, and look at the inputs.gdx and look at this cost FOM and see that, oh, look, these are, okay, this one's 19,256, and then this one was 48,140. So it's like, oh, good, the thing we changed is changed. If you wanted to, there's a nice utility in here where you could actually diff the GDX files, so that's pretty convenient. And then I'll just show you what the differences are so we can see what happens. But it's like, okay, our inputs came in, it looks like they're working the way we want it to. They ran, we have the bokeh training where we showed you how to look at outputs. So you could look at that if you wanted just to go in and compare these two scenarios and see what's different. In this one, you won't see anything different because they're historical years other than the cost. You should see, well, not even that much because there aren't really any batteries in 2010, 2012, but so that's basic of how to set up, changing an input. And that could happen for a variety of different cases. So we just looked at costs here, but if you wanted to, run an RPS scenario, you go here to the state policies folder, and you wanted to change the RPS requirements, you could come into this file and say, here, here's the RPS all is the RPS for all renewables. Then we have a solar carve out and wind carve out, and you could say, hey, I'm going to go into all the different states, and I'm just going to change these percentage values to be something different because I want to do a sensitivity on RPS inputs. So you could do that with any of the inputs. You could change them as they are and just save them off. You could save them as a new name to have a scenario, the scenario defined that way. It's a there's some of them like this rec percent. This one isn't. This one is, there's only one file. There aren't a whole bunch of files with different names. You could just call a different file with a different name. So this one, if you wanted to set it up to be different, you'd have to do some work to have different files, and it would choose which one to read. For this one, it'd probably be easiest just to copy in a file directly and change it, and then modify the inputs as you want, and then run the scenarios. So, okay, I gotta pull my notes, make sure I cover the next thing I want to touch on. Okay, so then one other piece that might be helpful here as you're going through inputs is sometimes inputs get modified quite a bit before they actually make it to the model, and you want to see things on the intermediate and see how they work. So let's take a look at the B inputs file. So this is the file that pulls all the. Well, let me back up one more step just to, as a more introductory piece. So as you can see in the process here, we've got the A write data is the first thing that happens, then our B inputs, then we get to the model, and then we'll get to the solve files, and then finally the E is where the report. So the write data files, this one is just going in and it's copying a few files over, and then it's just running a bunch of Python files from the input processing folder to take input files. A lot of times it's picking the thing you want and then outputting outputting the way you want. So for example, this write supply curve, it's pulling in whichever, you tell it which supply curve you want based on the cases file, and then it reads that in, formats it the way it needs done. So that's what all these files are doing up front. Then the B inputs is where things are now coming into the model. So a lot of times you'll have a parameter in here that you want to see what it looks like after you put it in. So you brought in a value into the model, and then its calculations are happening to it, and then it gets out, and you want to see what the intermediate pieces are. So in terms of working with inputs, that could be a thing that happens in here. So, as an example, one of the pieces I was working on not very long ago was this parameter called valcap, which I don't expect you to be working with, but this is just in terms of an example. It's got all these calculations that happen throughout, so lots of different lines, and I was checking to see something wasn't showing up the way I thought it was, and I didn't know where. So in terms of looking at inputs and how they happen, the way I was doing that is coming in here, creating a new parameter. So I just call something temp parameter with the same indices of whatever I want to look at. Since valcaps at IVRT, I'm looking at it the same thing. And maybe I want to do several of these. There's a few different ways you can do this, but we'll just do it this way because it's most straightforward. So I have, there's 3 different places I want to look. So I have a temp 1, a temp 2, and a temp 3. And now I want to look at what this parameter looks like after each of these. So I'll just come in here and say this equals valcap here. And I need to not create a semicolon at the end of the line. And then I want to look at it after this one. This one's going to be temp 2. And then I want to look at after this one. This one's going to be temp 3. And now I've got all of my, I've looked at it all 3 of these places. And so now I do an execute unload, which is what you do to get parameters out of GAMS. Just going to call it temp. And then I tell it that I want these 3 things written out. And if this is all the only thing I'm looking at, I could put an exit here too, just to make it go faster. So it'll just end the script after this point. So then I could just run the code up to here, and then it'll dump out this temp GDX with the temp 1, temp 2, temp 3, and then I could look at what val cap was at all 3 of these instances and make sure that the inputs that I put in, they're working the way that I think they should be working. So, Anne, do you have a question here?
I really like that method. Do display statements also work at this point in the code, or does display statements only work like after the model has solved?
Yeah, no, you can do display statements too. So display will print the values to the LST output file from GAMS. So you can do that too. That works fine. It's just that, this could be a really big parameter, and it's basically, it gives you a text editor that you're looking at this in. And I prefer this here. If you dump it to a GDX file, then you have this where you could do the pivoting and the filtering. So you could do this kind of thing and look at different pieces, or you could diff them between runs. So yes, they're both functionally the same. I just like the interactiveness of a GDX file in the viewer as opposed to a display, which is just in the text editor.
Yeah, that makes sense. I see why you like that.
Okay, then the only other thing I'll note is that as you add new inputs, you're probably going to break something at some point. So the debugging will be helpful. That's going to be our next section here that we'll talk about. So I guess just don't worry about breaking things up front, because it happens a lot. I mean, it's like that thing where if you forgot to add $1 year, so the model doesn't know what $1 year to convert this into. That's a pretty common thing. We do it. We break the model all the time as we're going through. So expect it to take a few iterations to get a new parameter or a new input into the model in the way you want. So so we've covered how to change parameters. Let me get rid of all this stuff we added in here, and then we'll go through how to add a new parameter. So let's say we have let's say we want to just put a multiplier in somewhere. Let's say in I guess one kind of thing that we've done is testing is like, hey, we wanted to look at what would happen if we changed the capacity credit of renewable energy, so that we said, right now ReEDS does calculations for capacity credit and says, in this region, given the profile of the load and the resources in here, if you add new solar, it'll get a 10% capacity credit or a 50% capacity credit, or maybe it's already saturated and you get basically 0% capacity credit. Let's say we want to just put a multiplier on the capacity credit to say what would happen if we undervalued or overvalued the capacity credit of solar. So we're going to now add a new parameter. So let's stick one in here. So we're going to make it a function of time. So we're just going to have a change over time. So whenever I'm adding a new parameter, usually what I do is I find a parameter that's in the same structure as whatever I want to add. So I know that we have a bunch of financial multipliers that I know that are just indexed by time. So for example, let's pull one up. I'm just going to grab CRFT. This is the capital recovery factor. It doesn't really matter what the parameter is. It's just that I know that it's indexed just by time. So it's like, okay, here's a parameter that's indexed just by time. So this is how I'm going to add it. So I already have code here for it. And I'll walk through what this means in a minute. But let me just go down to the very end. We'll just add it at the end. And so I just pasted my code here, and we're going to call this parameter RE capacity credit, CC for capacity credit multiplier. And it's just going to be indexed by T. And then I stick my semicolon at the end. I should have a description here that says multiplier on renewable energy capacity credits. And we should always add the units. So it's going to be just a fraction if there are no units associated with it. Okay, so we need to create our file or create our inputs. Let's go ahead and just make a new one. We're going to have it be, well, here, let me open up that CRF one so you can see what it looks like. So, so we look at our inputs case folder. You can see in the code already that it's looking in inputs case crf.csv is what it's pulling in. So here's our CRF file. So there you go. Right there. Okay. Here's our CRF file. So this is what it looks like. It's just got the years and then the value over here. This one is a post-processed one, so that's why it only has the odd years, is because it's only spitting out the years that were modeled. I did this for ERCOT run, so it only ran through 2030. But it's just, you have the years on one axis and or on one column, and then the values on the other column. So this is the format we're going to use for our new one, because that's what we copied for the input. So that's pretty straightforward. Let's say we want to define it for all years though. So we could go with 2010 and we're going to go 2011 and oops. And we'll go ahead and just dump this through 2050. And then we'll have our values. And let's say we're going to have it, we want the values, I don't know, I'm just making something up here, but let's say we want them to scale from 1, or let's say we'll, the model's starting in 2020. So let's have them go from 1 to 50% down here, and then we'll just fill these in with the trend. Okay, so we've got our value here. We'll save it as a CSV file, and I don't know what we should put it in. So let's go. Wrong one. Oh no. Okay, there we go. I'm just going to put it in the capacity data folder. It's kind of arbitrary for this, but let's just stick it there, just have a place for it. So we'll make it a CSV file. And this is our RE capacity credit multiplier. So if so we've got this guy in here. One thing we can do, which would just make it more convenient for us, is the comment character in GAMS is an asterisk, and this is just going to be read into GAMS basically as text. So we could add a asterisk here for the first column or for the first row, and then GAMS will ignore the first row because we'll see it as a comment. So we could put T there for the year and then values. That way we have some headers, so it's not just values. We've got this guy. There's two things. So two things here. One is in our inputs. Actually, I don't think it's in our inputs. I think it's in here. So there is our files for batch. This file says what files do you need to copy into the runs folder. So remember, so the runs folder is self-contained. This has a list of everything that needs to get copied over into that folder. So it's yeah. So if you have an input that just needs to be read, it needs to be in here so that because when a model or when you do a run, it's only going to look inside the runs folder for everything. It doesn't want to look other places, and that way the run is always self-contained, and you have everything in that run that you need to be able to reproduce the run. So if you lost, and you could save that run off by itself, and you could rerun it if you needed to. So we need to tell it to copy over this new file that we created. So we put it in the capacity folder, and we called it the RECC multiplier. So these are all in alphabetical order. So we'll just come in and stick it in here, and we'll copy that guy, and then take our file name and stick it in on top. So now it's going to copy that file from this location into our inputs case folder for the run. So back here for the run we already did, it's, it copied files into here. Now it's going to copy that in for our new run. And then get our code back. we need to make sure we give it, we copy this from CRF. We don't want it to read CRF. If we left it like this, then it will just put the CRF values into here. That's not good. So we want to instead give it the name of our new file. So we want to give it this guy as our new name. So it's saying it's going to look in the inputs case. This wildcard character is a slash. It's just doing it we use it as a wildcard, so we get the slashes in the right direction if you're on a Unix machine versus a Windows machine. And then it's going to look at this file inside the inputs case. And because we put it in the files for batch, it's going to copy it over into this inputs case folder. So what this code is saying is we've defined a new parameter. This is the name. This is the index. It's defined over T, which is the year set. So it's defined over years. And then here's where it's going to come in. And basically this include statement basically just says, take this file and put it in here directly. It's just like a copy paste. So, it's just going to have 2010, 1, 2011, 2. So that's what shows up here. We turn on this on delim to note that it's comma delimited. So it'll know how to deal with those commas as it comes in. And then this off listing just keeps it from printing to the LST file. So if we turn this off, then you could actually look in the LST file and see it read in. We do this for all of our inputs because otherwise this LST file gets massive because we have tons of inputs read in this file, and we don't want all of that in this text file because we'll end up with really big LST files. It takes longer to write those out and just to store them that we don't want. So so we've got it there. It's ready to go. We could so let's make sure we save this. I've done that lots of times where I run it and be like, why didn't it work? Oh, it's because I forgot to save. So let's go ahead and run this, and let's see, to test it, we're going to use the test case file, this one, because it's a lot faster. It only runs ERCOT. And the thing that we're going to change though is we're going to set the end year to 2020, just so it'll go even faster. So you can see there's two runs in here. There's ERCOT sequential, national sequential, but this one's set to ignore, so it's only going to run this one. So I'm going to save that. And we'll come back and we'll run it. So our batch prefix, this will be our RECC test. You call this whatever it wants. It's just what it's going to append to the beginning of your batch name. And then what's our cases suffix? Our cases, we're running cases test, so we want to tell it test is our suffix for the cases file we want to use. So say, hey, there's only one ERCOT sequential, this one, and then it pops up a new window where it's going to start running it. And this one will go a lot faster than the last one because it's only running ERCOT, which has 6 regions in it instead of 134. So you can see going through, starting with that awrite data with all these calls to Python. Excuse me. So once it completes those, then it'll go to the B inputs, which is where we added our code, and we'll be able to make sure that it ran and we didn't break anything. Okay, so now it's in B inputs, and it looks like it crashed. We probably did something wrong. So you get your debugging all in here at the same time. So it never made it to the solve. It just stopped there. So we could go to our inputs case. Well, one, we could make sure it got copied in here. So we have that RECC. I don't see it in here. Maybe that's why its problem is. Let's take a look. Oh, did we not save that files for batch? That could be the case that I didn't save it. Let's look. So when you're looking at this and the preview for what's coming, 4 asterisks, let's say what's happening. Error 282, which is unable to open include file. It can't open this file, and it looks like it's because it's not in there. There is no RECC file, so I think what happened is, if it doesn't say saved, we forgot to save this file. Okay, so that was our problem. We didn't stick it in here. So let's come back and run it again. And we need to give it a different prefix name. So we'll call this test2, and then we're still running the test suffix. There are ways we could shortcut this so it doesn't have to do this write data again, because it's already doing all that, but we won't cover that here. So once this goes through, one, it should work, and then two, we could go in and make sure it got put in the way we want it to. But then we'd be able to use that thing wherever we wanted. So let's go back to our inputs. So we've created this parameter. It's now available. It'll show up other places. So if we wanted to use it in the model, so if we wanted to go to the equation, reserve margin, and say, hey, we wanted to add this to a multiplier to our firm capacity from VRE, so we could go in here and now put in that multiplier and say, we want to do that. We want to take this guy and add it as a multiplier in here. Here's it for existing renewables, and then here's for marginal renewables. So we stick it against both of them and say, now we have this multiplier that's going to decrement the value of the firm capacity based on what we stuck in there. So that's it's pretty straightforward. Once you've added it, it's available for use anywhere downstream of the inputs. So in any of the C or D or E, because it's all there. So awesome. And oh no, we might have failed again. We're getting more debugging practice in here than we intended to. Again, and oh, okay, yep, sorry. Yeah, this is so you see it's saying we have a domain violation for the set starting in 2021. If you remember, we set the end year to 2020, but we specified the data for to go through 2050 because ReEDS normally runs through 2050. So our problem is that the T set for abbreviated run is just running from 2010 to 2020. We put the data in for 2010 to 2050. We want to actually define this parameter for a set called all T. And now all T just says, hey, this is all the possible T all the possible years we might want. And then it could read it in for whatever we want. And it's okay to still, back in here, we could still use just T when we stick it in here, because T is a subset of all T. So this is an allowable usage, even though we define it over all T. So if we go in here, save this now to cover all the years, then we'll try one more time. This is just standard ReEDS work now. It's like I just did a set of tests where I was merging in the 2022 version of our database, and it took me I had, you're counting here, I've got test 2, test 3, it was number 16 before I got everything right and working. So maybe that means I'm not good at what I'm doing, but it tends to be an iterative process, which is where some of these shortcuts are nice. You don't have to rerun the same thing that improves in the same outputs. Okay, so we're gonna start. We've got 15 minutes left here before we need to close out. So what we're gonna do while this starts running is we're gonna start talking about outputs and how you now generate new outputs. And then we'll take a look at this one in just a minute. So, and it looks like we didn't crash it. So let me get our outputs folder open, and then this guy might actually be far enough along that we could get it to work. So we're going to open eReport and eReport dump. So they're coming, they're at the end because they're the E's. Those are the last ones. But since this is far enough, let's go take a look here. So we have now our test. So you can see it's actually running now. It's getting to the solve, and it's finished solving. It's at eReport now. We could go into our test 3, and we can again look at that one. It's here now, so we could see the files here. So we just want to look at it. This one's not that exciting. We just copied it over, so we don't expect anything to be different. But we can look at the inputs.gdx and make sure it got into the model and what it looks like there. So we have this RECC multiplier. It's in here. It looks like what we expect it to. So we're happy with the way it's working. Okay, so let's go back to talk about our outputs. So once the model runs through, so it does the B inputs, it does the C where it sets up the model. So all the equations are defined in here. So all the model equations, all the objective function, and the D is where it actually does the solving of the model that has the solve statements. Once it's done, then we get to this e-report. So e-report is where we report out all the values that we want to generate. So we'll see that in a run we do. We'll have this outputs folder, which gets populated with a whole bunch of CSV files and this GDX file. And then it also generates these bokeh reports. We've got the other training on bokeh, but it's got the HTML viewer where you could come in and see solutions in an interactive way. And there's tons of outputs and a lot of stuff you could look at here. So, but we'll skip those right now. What I want to focus on is just getting a new output out of the model that you might want. So right now, the way this is set up is this, everything that's available upstream, anything that's been defined upstream is all available here. So all of that is available. We've defined a bunch of parameters where we get outputs. And then at the very end of this, we execute, unload a GDX file. And that's this file in the outputs. And it has all of these parameters in it. So all these parameters are in that GDX file. And this is what we use for putting things out. And so GAMS is kind of weird in that you can't just dump directly to a CSV. I can't take, or at least I don't know how to anyway. You can't just take a parameter and say, write this to a CSV. You can do that to a GDX file. And then you could write from a GDX file to a CSV. But because of differences in command or in runtime execution versus compile time, you have to do these as separate steps. So in this e-report, we generate a GDX file with the parameters in it. And then we have a separate e-report dump that runs afterwards. All it does is it reads that GDX file, it reads the same GDX file, and it takes the values inside that GDX file and turns them into CSV files. So all of these CSV files in the outputs are just all those parameters are already in this thing. It just can be annoying to get them out of here. So all of that stuff is here. So we have like cap firm is in here and you can look at it. And then we write out a cap firm CSV file that now is, it's just a CSV. So we could use it. This is what bokeh reads. Bokeh can't read GDX files, it reads the CSVs. Well, it could read anyway. Python can read GDX files, it's just a lot slower. So we go the CSV route and it's a lot more flexible. So you could do this for post-processing. So I guess, so in terms of getting a new output, a couple pieces. One is sometimes there's already an output created. So it's not that big of a deal to just add it to the, so if it's already created, maybe you just need to put it into the GDX file. So let's go back to our code. So if there is an output already you already want, it's just not in here, you just put it in to this list and then it'll get into the GDX file. And then if it's in the GDX file but not out as a CSV and you want it as a CSV, then you just come to the e-report dump and just copy a line that's already here. You don't have to understand what it's doing. You just copy a line, just know the symbol is whatever it's called in the GDX file, and then here's what you call it. Here's the name of the CSV file, and then you're done. And it'll fall out with everything else. If you want a new output, this is straightforward, other than if you've never used GAMS, GAMS language could be a challenge to work with, but if you know GAMS or have something you want to use, sometimes you could often look at examples and use it to model what you might want. So let's say you wanted to look at a generation output, we could already look at, so our variable is gen. So when you're getting things out of GAMS, every variable has a level. That's the value that it takes. They have marginal values, so that's you do dot m to get the marginal values. They have an upper bound and a lower bound, so you dot up and dot low to get those. So let's say we want to use something where we're calculating something with generation. So let's just get a we're going to grab just a generation output. So we're just looking at gen until we find something we might want. These ones are all too weird for us. Let's find something more normal. Here we go. Okay, this is saying we want gen out annual. So this is our annual generation. Here's our generation by IVRT. Let's say we want to create a generation by state is the output we want. So we want to make a new parameter that's generation by state. So it's going to be by technology and by state and by year. So we need to define this parameter. So you could, I mean, if you're just doing a one-off, you could define it anywhere. We do have this list up front where all the parameters are defined. So we could stick it in this list if we wanted to be formal. And give it units. It's going to be it's going to follow this format. It's going to be megawatt hours, and it's going to be annual generation by technology and state. Okay, so let's go back to where we have this, and then we could use this gen out because it already has what we have. So this is annual generation by ReEDS region, and we're just gonna convert it to state. So we're gonna do the weird GAMS thing where we're gonna sum over the regions, and we want to do it for the $sign. You could think of it as a for or an if. We have this R state set that maps R to state. So we're going to sum over any R that's in that state. So this basically says sum R if that R is in the state, and then we're done. With our sum. And now we have this output that's generation by state. We wouldn't need to do this because Bokeh already does this. You could do all this in Bokeh, but this is illustrative of the kind of thing you do. And then you just make sure you add your gen state down here. I'm just going to stick it at the end for convenience. So it gets written to the GDX file, and then you come out if you want it to be a CSV. We do the same thing, and I'm just going to stick it at the end where we'd say, oops, copy that. And our parameter is called gen state. And if we could give it a different name here, we could call it the same thing. I'm just going to call it the same thing here. And then we've now got this parameter that'll get dumped out as a CSV called gen state that'll have states and then the annual generation in each year. It'll be by technology still, because that's how we defined it up here. We defined it high as a technology set, so we kept that. So it's going to be by technology, by state, and by year. I'm not going to run through and test this just because of timing, but that's to add a new output. That's all that it takes. It's pretty straightforward in terms of sticking a new thing in here and making it work, as long as you're comfortable doing something in GAMS. But a lot of times, if you have something, it's like, oh, I have this output, I know I want it. You can look at the name of it, trace it upstream, and see how it was written, copy it, and then just adjust it rather than trying to develop something from scratch. Or getting it something might be good just to have in ReEDS. You're always welcome to contact us. We're always happy to take requests for, hey, it'd be great if this thing was in the model or if this thing was output. We think it's pretty useful. And you can pass that along, and we'll look at doing that. So just to make sure, you want to give us a little break before we get to debug, I'm going to stop recording.